Good day. I am Emmanuel Villanueva, and I am here to demonstrate the prototype model that has been created for the study determination of pupillary distance using YOLO algorithm. So, to begin with, I would like to inform everyone that I have created a 3D model of the device so that you could see the whole image of the prototype. From there, I will be explaining as to what are the different components and how it's being used in order to achieve the results that we have gathered for the study. So I would like to start the demonstration by showing you the 3D model of the device. So basically what we have here is a whole 360 picture of the device that was created with Tinkercad in order to demonstrate how the usage of the created device would be like. So to begin with, let's start by demonstrating the different components found in the front side of the prototype. We have here a 3.5-inch LCD touchscreen that could act as the primary input device of the prototype. However, if you look at the side, you would see 4 different USB input wherein you could use mouse and a keyboard as optional inputs. There will be 2 extra USB slots, one of which I have used in order to use an LED lighting to make sure that the prototype takes clear and bright pictures of the subject's eyes. On the top portion, there is a small slot here, and this acts as the input for the power supply of the device. The whole device is powered by a 5-volt power supply, which could come in the form of a battery or a power bank. Behind this enclosure, a small bump of resin acts as the shell of the Raspberry Pi, which is placed inside. So the Raspberry Pi itself is protected from any external factors or external damages that might be the result from overusing the device. In the back side, there is a pinhole type camera of the prototype. This is responsible for capturing and analyzing the images of the patient or the subject. Once the subject would use it, they would have to place their face, their chin or nose near the bottom part of the prototype and align their eyes with the camera. So the whole process, the researcher is standing in the front side of the prototype, allowing him to capture the images or browse through the images while also monitoring what is happening in the screen. And while on the other side, the back side, the subject would simply place their face near the bottom of the prototype and have their eyes scanned. So it's a very straight and simple process of capturing the subject's eyes. However, it is also worth noting that the whole device must not be moved in order to ensure that the images that's being captured with the prototype is steady and accurate. Here's the actual image of the developed prototype. You can see the front side of the device, wherein, as I've mentioned, there is a 5 volts power supply cable plugged into the device, the LED lighting, and the optional keyboard or mouse input of the device. This is used in order to fine-tune the movement of the cursor or when entering commands using the terminal input for the Raspberry Pi. And this is the backside of the prototype, wherein, as I've mentioned, the subject would have to place their face or the bottom part of their face in order to align their eyes into the camera. They just have to simply stare at the camera for a while as the image is being captured, or rather their eyes are being recorded, and then the image would then be subjected to image processing and have YOLO algorithm determine the distance between their pupils. The black line that was drawn on the prototype actually serves as a guide for the peripheral vision of the subject in order to make it much more easier for them to know where to align their eyes to ensure that the camera gets a steady picture of their pupils. When gathering data, first we collect the manually measured pupillary distance using a pupillary distance ruler. In this particular case, we could see that the subject exhibits 63 millimeters in terms of pupillary distance from left to right. In the prototype, we could see her pupils and pupillary distance has been detected to be 62.56 millimeters. So the difference is very small. This is another subject that have used the prototype in the demonstration as well. We use the same pupillary distance ruler, however this one measures it individually between left and right, but the results would still remain the same. So you could see that there is 27 for his left eye and 30 for the right eye. This is equivalent to 57 millimeters if added. So the distance between left and right pupils would be 57 millimeters. This is the subject's actual image inside the prototype once his eyes were scanned. The YOLO algorithm was able to detect his eyes and compute the distance between the two pupils. This is to emphasize the subject's pupils, which would be the green dots, and the distance between the two pupils would be demonstrated by the green line, while the boxes demonstrate the eyes of the subject itself. The subject has scanned his pupillary distance and the results is 58.13 millimeters. So that covers how the prototype is going to be used. I would like to thank Tinkercad for creating the program that enables users to develop 3D models without the use of any extra software. I would also like to thank Jason as one of our participants in this study. He is the guy that is this demonstration. Well, I would also like to extend my deepest thanks to Rian for allowing me to use her as a subject in this study. So thank you so much for listening and have a great day.